Now let's take a look at the 30, 60, 90. For the 30, 60, 90, we're going to start with an equilateral triangle. Here's our equilateral triangle right here. Each side is 2. What is the measure of each angle? Earlier I mentioned that every angle in a triangle adds up to 180 degrees. Now this triangle, because it's an equilateral triangle, all these angles are congruent. That's why I wrote these little arcs on each angle. Now if all these are the same, what do they have to be in order to add up to 180 degrees? One way to do that is to take 180 degrees and divide it by 3, because there's 3 angles, and you would get 60 degrees. So every angle measures 60 degrees. Now we're going to draw a height from one vertex. Now vertex is just another word for corners in shapes. So let's erase these really quick, and we're going to draw a height. So Normally heights are dotted, so I'm just going to draw dotted lines. So there's my H. Now if I draw it straight down, that's going to form a right triangle. Right there, a right angle. Okay, this says, notice that the angle was, we're going to say bisected. And you can see that, it's kind of evident. This angle right here was cut in half. That's what bisected means. So that means this is now 30 degrees. The opposite side, which is talking about this right here, was also bisected. So we're going to say bisected right here. Now if that was bisected, what would the length of this be? That would be 1. So now we have, here let me draw our triangle that we have. This is the height, this is 2 right there, and this is 1. And we know that this is a 30 degrees, this is 90, and this is 60 degrees. So how will we find our missing side right here? We can use the Pythagorean Theorem again. Now this is the hypotenuse, so we're going to say 2 squared equals h squared plus 1 squared. 1 squared is 1, and 2 squared is 4. So now we have h squared plus 1 equals 4. So we subtract 1 from both sides, and we get radical 3, no, I'm sorry, jumped ahead there. We get 3 equals h squared. To get rid of the squared, we have to square root both sides, and we get radical 3 equals h. So now we have this triangle. This would be the 60 degree side, because it's a bigger one, 30 degrees. Now these degrees can actually switch, like you can put them up there and down there. It doesn't matter which one's on top, which one's on bottom. And then we can fill out the rest of the sides. See, the 60 degree side is 1, the hypotenuse is 2, and our 30 degree side is 3. That's actually how I remember where the radical 3 goes. It goes with the 30 degrees. 3 and 3, that's how I remember it. But there's other ways you can remember it. Come up with your own. We can now we can use similar triangles with the 30, 60, 90 triangle to solve other triangles, just like we did with the 45, 45, 90. So now this one has a 30 degrees on the bottom. I'm going to draw my 30, 60, 90 in the same orientation, so it kind of helps us see it. So I'm going to put 30 degrees right there. That's well, we know it's not B. This is 60 degrees. Alright, so remember, radical 3 goes with the 30 degrees. The hypotenuse has a 2 on it, but it doesn't have a radical 2. Nope, it doesn't have that. That's what the 45, 45, 90 has. So this one doesn't have a radical on it, and this is a 1. So this triangle is similar to that triangle. That means we can set up a proportion. So let's go 6 over 2 equals, so it was 6 over 2, so I did this triangle on top. That means I got to do this triangle on top again, so A is over 1. A over 1. Here we don't have to do cross multiplication, we can just simplify. A divided by 1 is A, and 6 divided by 2 is 3. So A equals 3. Really cool. Now let's find the last side. We can, since we know these two sides, we could use the Pythagorean Theorem. But I'm going to set up another proportion instead. So 6 over 2 equals, that was 6 over 2, and then we're going to have B over rad 3, because those are corresponding sides. So B over radical 3. Now to solve this, I'm going to cross multiply. Man, there's so many ways to solve this. Well, I guess I've already cross multiplied before. Let me do this a different way. Let's simplify this side. That's 6 divided by 2, which is 3. And on this side we have b divided by radical 3. Now to get the b alone, we just have to do the opposite of dividing by rad 3. So we're going to multiply this side by rad 3. By doing the inverse, the opposite operation, we know that they're going to cancel out. I'm going to multiply this side by rad 3. Now because this is not a radical, we can't multiply this 3 and this 3. So we just write it out. So it says 3 times radical 3, that equals b. And that's our other answer. So there's our a and our b. Now at the end of the notes, I want you to write something down. Just what do you think about these triangles? What makes them so special? Write it down. We'll discuss it in class tomorrow.